The last of the basic types of graphs that we would have for polar graphs would be lemniscates and spirals of Archimedes. So the equation for lemniscates would be r squared is equal to positive or negative a squared cosine 2 theta, and that gives us a horizontal lemniscate, and r squared is equal to positive or negative a squared sine 2 theta. That gives us a lemniscate rising to the right. And if we have r is equal to a plus b theta, then we get a spiral of Archimedes, sometimes also known as the logarithmic spiral. So we have the same process as graphing other polar graphs. We test the symmetry, get the table of values that is similar on how we graph sine and cosine, and then work with symmetry for us to be able to produce the graph. So, for example, we are asked to graph r squared. R squared is equal to 9 sine 2 theta. So, as practice, pause the video and try to find the symmetry, perform the symmetry test on this equation, just like how we did before. Alright, so assuming that you did pause the video, so let's now try to sketch the graph of this one. Now, as we can see, it's r squared and then sine 2 theta. So therefore, we say that this is a lemniscate or a figure 8 rising to the right. That's what we expect, what the graph will look like. So with this, let's now have our symmetry test. For the polar axis, we again start with r, negative theta. It will be relatively easy. So that's r squared is equal to 9 sine 2 times negative theta, and we know that since that is sine negative theta, let's move that up. This becomes r squared is equal to negative 9 sine 2 theta. Not the same. So if we're going to check it with negative r pi minus theta, we're going to get negative r squared is equal to 9 sine of 2 times pi minus theta. Simplifying this, we'll get r squared is equal to 9 sine 2 pi minus 2 theta. Expanding this, we're going to get r squared is equal to 9 multiplied 2 sine 2 pi cosine 2 theta minus cosine 2 pi sine 2 theta. Sine 2 pi is 0, and so this is a product that gets cancelled. Cosine 2 pi is positive 1, but since there's negative, it's negative sine 2 theta times 9. R squared would be equal to negative 9 sine 2 theta. Still not the same, therefore, we can assume it's not symmetric with respect to the polar axis. There you go. With respect to the pi over 2 axis, so with the pi over 2 axis, we first check with negative r, negative theta. We already know what's the result with negative theta, that's negative 9 sine 2 theta. We also know the result with negative r, that's simply r squared, so it doesn't work here. So if we're going to check with r and pi minus theta, we already know the result with pi minus theta. It's r squared is equal to negative 9 sine 2 theta. This is from pi minus theta. It's the same, so I don't need to compute again. We get that, and still not the same. So therefore, it's not symmetric with respect to pi over 2 axis. How about if it's let's check if it's symmetric rather with respect to the pole. So that's negative r theta. Nothing changes on the right side. That's 9 sine 2 theta. Then negative r squared, which is positive. That is positive. And it works. So therefore, it's only symmetric with respect to the pole. Now that we know that it's symmetric with respect to the pole, we can now then try to do its the table now, and we are now sure that it's symmetric with respect to the pole. It's either quadrant 1 and quadrant 3 have the same, 2 and 4 the same. But since it's rising to the right, we should expect that it's like that. Quadrant 1 and quadrant 3 would have the same figure. So it's the same, since again it's 2 theta. We would need to have 2 theta is equal to 0, 2 theta is equal to 2 pi, then divide both sides of these equations by 2. So therefore, we'll have theta is equal to 0, theta is equal to pi. Since we end at pi, we divide it by 4. So therefore, our table of values, which I'm going to write here, theta now would be, theta now would become 0, pi plus pi over 4, pi over 4, pi over 4 plus pi over 4, pi over 2, then add another pi over 4 to get 3 pi over 4, then pi. So 2 theta would then be 0, pi over 2, pi, 3 pi over 2, 2 pi. So r would then become, that is 9 sine 2 theta. So 0 times 2 theta is 0, sine 0 is 0, times 9 is 0. So sine pi over 2 is 1 times, that becomes r squared. Now, I forgot to add r squared because that is what the equation is, r squared. Since it's r squared, we need to add that first because that's r squared is 9 sine 2 theta. Then we get r, we get the square root. Let's write the equation here again. R squared is 9 sine 2 theta. So for example, for pi over 2, sine pi over 2 is 1. So r squared equals 9. So to get r, that's actually positive or negative 3. Then we'll just check later on which one is, because it's a Lemniscate present to the right. So then we'll get sine pi over 2, sine pi here. Sine pi is 0 times 9, 0. Write 0 here. So sine 3 pi over 2, this 2 theta is 3 pi over 2 here already. So sine 3 pi over 2 is negative 1 times 9, that's negative 9. But the square root of negative 9 is imaginary. That's 3, positive negative 3i, which we don't usually add. We don't add because there's no imaginary numbers on the polar coordinate system. So for sine 2 pi, that's 0, 0. So this is only what we get. Now plotting our, let's place again our polar axis, pi over 2 axis. So we only have theta, which is pi over 4, so that's 3 pi over 4, 3, then pi over 4, and negative 3 pi over 4. So for 3 pi over 4, this is pi over 4, 1, 2, 3. We have here the negative 3 pi over 4, 1, 2, 3, here. So it's a Lemniscate, so it should somehow look like an 8, which, let's make one a bit more thicker. There you go. It looks like an 8, yes. It's rising from the right. So that's the graph of r squared is equal to 9 sine 2 theta. So, pause the video and try to see if you'll be able to graph on your own using symmetry tests. R squared is equal to 4 cosine 2 theta. Okay, assuming that you actually pause the video. So there. So, based from the form, this is a Lemniscate. A horizontal Lemniscate, sorry. A horizontal Lemniscate because it's cosine. It's horizontal Lemniscate. So we expect that it's symmetric with the polar axis, pi over 2 axis, and actually the pole. Why do I expect that? We'll check the graph here. Here, look. Polar axis, pi over 2 axis, and actually the pole. They are symmetric. So, I leave the computation to you for this, and actually the computations are quite easy because if we're going to double check, oops, for symmetry test, I leave the computation to you, but if you're if you're going to compute for this, it is actually symmetric to all. It's symmetric with respect to polar axis, pi over 2 axis, and pole. I leave the computation to you, which is here is relatively easy. So now since it's 2 theta again, so based on what we had a while ago, if it's 2 theta, our values of theta would be from 0, pi over 4, pi over 2, 3 pi over 4, and then pi. So the 2 theta, this becomes 0, pi over 2, pi, 3 pi over 2, 2 pi. Then we get r squared first before we get r. So we get that the cosine of 2 theta is 0. So cosine 0 is 1 times 4. That's 4. So this becomes positive negative 2. Cosine of pi over 2 is 0 times 4 is 0. So we get 0 here. Cosine of pi is negative 1 times 4. That's negative 4. So this is imaginary. We don't place that there. Cosine of 3 pi over 2 is 0. Square root of that is 0. Cosine of 2 pi is 1 times 4. So that's 4. Then plus minus 2. Alright. So we'll only get this and this. So 0, we have 0, 2, 0, negative 2. Here. It's actually the same because pi 2 pi, sorry, is here, and then negative 2 pi is here. So, oops, let's just draw again our polar axis. Oops. Here, polar axis, pi over 2 axis. And as we can see, these are just the 2 points that we need. So all we need to just draw our Lemniscate. It should be like something like that, and curve like that. So there you go. This is the graph of r squared is equal to 4 cosine 2 theta. And that's how we graph Lemniscates.